Oh, we didn't. Oh, I didn't start it.
It's good. Just,
Yeah.
sorry.
Oh well. That's all right. I didn't say anything exciting. So I also founded OpenRevit.com. Hopefully everybody in this room has visited that site. If not, go there when you get home. So yeah, I've been in the industry about 10 years. I'm happy to have joined CASE at the beginning of the year. Great group of guys. Definitely check out their site for news and stuff going on with the company. And why am I here? So I got into engineering because I used to build cars when I was in high school, or rebuild, I should say, cars when I was in high school. So I got into engineering, and of course, in college they teach you manufacturing and stuff, and we didn't really get to work on any cars. So, and ultimately I didn't even go into manufacturing. I ended up as an HVAC engineer. So yeah, I've been using BIM for about 6 years as an MEP. You can't Revit. You can't say you used it much longer than that. Building systems, beta 2. Anybody else in the room? Who's around? Paul. So why are we here today? Okay, so why is BIM great for MEP? So there's been a lot of frustration in the MEP industry with the adoption of BIM. It's been rough for a lot of companies, kind of understanding what it is. It's definitely a change in company workflow. But I think for MEP folks, I think it's a huge, positive impact on the industry for a number of reasons. And I've listed a few up here, but I mean, the primary one is that our industry is data-driven. We rely a lot on numbers and calculations. We probably have 1 million Excel spreadsheets that we, have to deal with on a daily basis. And the unfortunate piece of that is that that's just kind of information that's loose, hanging out there, not very well organized. And the great thing about BIM is that you now have kind of a single source model that can contain all your information. So if you need to, scheduling, if you need to do calculations, not only are you pulling information that you've generated as an engineer, but you're also pulling information that is up to date and current from the other designers and the architects that you're working with. So there's a huge benefit there, because I know from personal experience that I've definitely lost a lot of time and kind of redundancy, the copying of information over and over from Excel to somebody's notes, things like that. So it's definitely a plus there. You get the plus of visual feedback and coordination, which is huge. Just 3D in general, not even BIM. I mean, I think we're all there at this point. So the first topic I'm going to talk about is kind of at the management level, what I've kind of learned, and I think this is probably maybe one of the most important things I'm going to talk about tonight. So we did a lot of extensive work when I was at Kling to kind of build a framework that we're going to measure our buildings against. And the AIA has a document. You'll have to forgive me. I don't know the name of the document. Where they cover these LODs. E202, thank you. I knew it was E200 something. So they cover all these 100 to 500 different levels of development for BIM, and what we noticed as the MEP folks, and I'm sure the architects could say the same thing, was that the way the descriptions were for these LODs didn't really fit kind of the MEP building systems. So when we wrote kind of our baseline contracts at Kling, we wanted to make sure that we were very transparent with our clients on what we needed to deliver to satisfy our contract. And if you guys don't have BIM implementation plans and LODs and BIM contracts with your clients, I mean, there's a huge liability there, and there's a lot of gray area as far as what you owe them and what level of detail you're going to build against. So kind of on the left is kind of maybe a summarized version of the level 300, where it's accurate in terms of quantity, size, shape, location, and orientation. What we found is turning over a 300 level MEP model, that wasn't a good enough level of detail. So we went into an extensive amount of detail, and this is just a paraphrase from the document, but you can see 300 level elements contain specific information relating to, but not limited to, performance, size, make, model, flow characteristics. The information is directly linked to the BIM database, may directly and parametrically influence and modify other elements and information contained in the relational database. So we wanted to be very clear that we as a company, when I was at Kling, we didn't just give you a 3D coordinated, model. It wasn't just a bunch of dumb 3D elements. We put a lot of information into the model, and all the elements on a systems level, they interact with each other. So things like flow, airflow, water flow, the power required for the mechanical equipment, the impact that has on the electrical calculations. These were all things that we wanted to make sure that we used and that we were clear on how much detail we were going to provide to the client. So that's a big, does everybody in here kind of have kind of like an LOD document with their company? So one of the appendixes to this LOD document was that we had a huge matrix. A lot of people are using like the Uniclass documents. We chose on the MEP side to kind of build a matrix of specification sections. So we would basically list every spec section for division 15 HVAC mechanical, and we would in the spreadsheet we would say, all right, at SD level we're going to provide level 100, and we would go down the list, every item. We're talking valves, fans, equipment, fittings, whatever it was. If it was an item in the spec, we wanted to make sure that we said this. We wanted to make sure that that the client knew what we were providing. So we would kind of set a benchmark, and we'd say, this is our typical building. We're going to provide this level of detail, and then we would adjust it to suit the client. But we would go through each phase, and we would identify what level of detail each component in the model would have. Yeah. Yeah, for those of you online, I'm not going to be able to repeat everything that Robert just said. But to paraphrase, at least part of it is, there are obviously certain elements that require. It's not like we would go down the spec list and everything was a level 300. Absolutely not. There were specific items that are of importance, and on the MEP side, it was primarily the level 300 was anything that was scheduled, because the scheduled information. And we used live schedules. We didn't do schedules in AutoCAD. So all that information was contained in the BIM. And so pretty much anything that was scheduled is an automatic 300. So if you guys are kind of thinking, what is 300? If you schedule it, that's a 300. You guys have any questions about how I? Obviously, it's a huge document, so I can't show you everything in the document, but are there any questions as far as like how in the past, the companies I've worked for, how we've modeled stuff, and to what level of detail? Nope.
Is there a PDF that shows the LOD sort of benchmarks and what level of detail corresponds to that number? Say 300, 400, 500, or?
The way, so what we did, and the question was, is there kind of a matrix or a way to determine what each level is? Yeah. So we had to put it, verbally. We also had like a visual representation of what like a level 300 model was. I don't think that really gives you the sense when you're talking about like BIM and information. The visual stuff you can't tell what's embedded in each piece of content. So we had to do something like this where we would basically write out a description. And that was the only way. So like 300 stuff, as you can see, like, all the stuff that you would schedule, things like flow, all the connected systems, all that stuff, that's 300. If I were to just throw a boiler on the floor and not, do my schedule in AutoCAD, and do all my schematics in AutoCAD and stuff like that, and then send out a 3D coordinated model, that's not really the kind of embracing BIM. So we wanted to make sure that we provided all that information so that when you turn over these models, for the client, for facilities, for the contractors, that they're working with the same information that you were. Again, it's kind of that, what I talked about in the beginning as far as being able to reuse information and have a single source of information. It's another question.
According to area contract, LOD 300 is also for the generation of shop drawings. Do you think the model that you generate and name as an LOD 300 is good for the shop drawings?
So the question was, do I consider LOD 300 good enough for shop drawings? I don't think it is. I wouldn't feel comfortable saying that you could fabricate from do sheet metal fabrication off of my level 300 ductwork. I mean, there's a lot of work that goes into what builders, what contractors do, and I wouldn't want to take away from what they do and the amount of coordination that still goes on site after the design process is over. So I mean, I wouldn't feel comfortable saying that. I think that'd be a huge liability to kind of go from a level 300 into shop drawings. Robert, you had something to say?
Yeah, what that means is that the model is enough detail that someone can create shop drawings by reviewing the data in the model. It's still adding their expertise and knowledge to create the shop drawing or the shop model. But the LOD 300 elements themselves are not the shop model. That might be what the architect and engineer is creating to communicate to the next one. Sorry,
Yeah, we need a mobile microphone. Yeah, so it's a discussion. I mean, we could probably do an hour discussion on contract. We probably do an hour on every slide I'm going to show you. So I'm gonna try to get through them, and we can go back and talk about other things, the interesting stuff in detail. But yeah, you can talk about contracts forever. I mean, there's a lot. It's a huge change for us. So one of the other things I'm going to mention, kind of an overview, is company standards. So I think this is a huge pain point for a lot of MEP firms and AE firms, is kind of integrating your company standards using a new platform. So you're obviously probably coming from a CAD platform, an AutoCAD or MicroStation, something like that. And you want to bring over all your symbology and all your line representations and annotations and things of that nature. So one of the worst things I've found in a lot of the companies I've worked with is that they kind of they end up settling for kind of the out-of-the-box content and annotations and stuff like that, and they don't do enough customization, and that's a huge problem. You definitely want to invest a significant amount of time making sure that you're creating that you're either creating content or modifying content or creating templates and standards specifically around, BIM. So obviously, a lot of people I talk with, they want everything to look like CAD, and it's not going to happen. I think 95% of what we do, at least in the Revit platform, can look like CAD. I mean, all those screenshots up there, not the 3D stuff, but all the 2D stuff. That's smart. Those are smart elements. None of that stuff is CAD line work or simple line work in Revit. So every piece of text, every piece of symbology on there, is intelligent and smart, and that's exactly how it looks in the model. So a lot of times people get started, using like Revit MEP or something. What they'll do is they'll literally take their CAD, cover sheet, their MEP kind of symbols and abbreviations lists, right? And they'll literally copy and paste it into Revit, and that'll be what they use. And contractors will be looking at the symbols, and they'll have no idea what's going on because they don't match. So I can't stress enough the importance of investing time into your standards. And like I said, I mean, maybe when you first started using Revit, it wasn't quite what you needed it to be from a graphical standpoint. But like I said, this is literally identical to the CAD stuff, and I promise you, each one of those elements is an intelligent element, and that's how it looks when we work in BIM. So the volume dampers, fire dampers, things like motorized dampers, the duct size, the duct systems. This is all reading information about the elements in the model. So to go back to another point I had on that first slide, it really reduces error, and there's no manual. Nobody's going around and putting a dumb text next to this stuff, and it gets updated later, and nobody knows what's going on. So I mean, that's a huge point. Now, the engineers in the room, do you agree that kind of developing standards is a huge piece of the kind of BIM adoption? Because a lot of the higher ups, they'll do a QA or something like that, and they want it to look like the same, look the same as it was for the last 30 years. So the best you can accommodate them is always good. And unfortunately, not to knock Autodesk, but they really didn't come out with a kind of a cohesive set of symbols for the MEP folks, and I'm sure it was the same on the architecture side, but I definitely feel it was lacking. So, things like proper elbows and valves and things like that, a lot of the stuff we use, creating detailed families is an art in itself. So it's not something you learn overnight. So it's definitely something you got to invest in. Conceptual analysis. So I talk to a lot of engineers, and they don't, they think that they're going to waste all their money kind of on concept design, SD level, DD level stuff. And I think they're focused on like drawings and documentation and things like that, and they kind of lose sight of the fact that when you're dealing with an architectural model early on in a design, that there's a huge advantage for MEP folks because we're very, analysis driven, so calculation driven, like I said in the beginning. And being able to take, takeoffs from buildings and get areas and do preliminary energy modeling and preliminary load calculations with just the model they receive from an architect, it's a huge, it's a huge time saver. So, we would use things at a conceptual level, things like zone planning. It could be, it could be HVAC zoning. And it's important to understand that, and I've said this before to a lot of people I talk to, is that it's important to understand that maybe with a BIM kind of workflow, you're going to change maybe what you would typically show at an SD level. Maybe you typically show Raja diagrams, one-line diagrams, things like that. Maybe you don't do that anymore. Maybe you do things like preliminary calculations, preliminary equipment sizes, HVAC zoning diagrams, early energy analysis, things like that. Getting kind of a general overview of the building and how your systems are going to integrate into it. You kind of leave those one lines for DD. So maybe you want to take a different look at what you're doing altogether. So part of that is understanding deliverables, what you want to deliver. Front loading, back loading. You might want to change your typical workflow. Spend a little bit more time maybe in the beginning. Maybe your company wants to spend a little bit more time on the back end. So every company is a little different, and depending on what your deliverables are, they're going to be a little different. So let's see if there are any questions here. Do you guys have any questions?
Can you clarify that? Front load to back load? What do you imply?
Hold on a second. I don't know what that said. So the question was, what do I mean by front loading or back loading? So when you do kind of your work planner, right, and your for the life of the project, you're going to kind of try to split up your team and how many hours you spend at each phase, and how many people, how many man hours you're going to need at each phase. And the point I really just wanted to make is that the old style, when you were using kind of a CAD platform, the balance of your man hours over the course of a project might vary now. I'm not saying it's going to take longer or shorter. I'm not going to start that argument tonight. But it's more, where do you want to focus your effort, right? Because you may be receiving a kind of a conceptual model from an architect, and you might not want to spend a lot of time. You may not be, maybe you don't deliver anything at SD, at a schematic design level. Maybe you wait till that DD level where things are more solidified to start doing your calculations. And there is no right or wrong, but it's important just to kind of look at the workflow that you have and adjust it. Adjust where you put your time. I'm not saying, like, typically MEP companies, you start off saying, oh, I have 2 people working on the job, and then at the end of the job there's 20 people working on the job. You don't want to do that. I mean, that's kind of the typical mentality, and I think we can spread that out. You can have maybe 5 people on a project over the entire lifespan and not have to dump 20 people at the end of the project if done properly, and if you plan properly, and take advantage of all these things that I'm talking about. So I think that's really important. Hey, Robert, I don't know how to, these are hard to see. I can't read these questions from online. I can read that one.
Yeah, you're just scrolling back and forth.
What's this one up here?
Don't know.
Oh, okay.
Can you pull that down?
Oh, I see. So it's the same question. All right. So this one, so the question for the, well, I guess you guys can see it, but the question is, when does one decide when the design model becomes the construction model, and where do we draw the line on information between the 2 parties? Well, I mean, I don't know that there is a line to be drawn there, right? I mean, I don't know if there is a line between what a design is and what a design model is and what a construction model is. I mean, at least it's not a hard line, right? So I don't know exactly how to answer that. I mean, the majority, here's the thing. I mean, what you have to understand is you're in a position where you're able to turn over just an incredible amount of information to your clients, to your owners, to the contractors, and don't sell anybody short. Don't turn over just the 3D model with no info, and let the contractors sort it all out and have everything, again, be done 3 times over the lifespan of the project. These are your designs. You need to take all that information, hand it over, and make sure that your design information is carried over into construction. I dealt a lot with, in the past where you hand over, a sheet metal design, and you get shop drawings back, and the contractor did whatever they wanted. Now, there could be a number of reasons. Maybe you really didn't coordinate it very well, and they had to do something different. Maybe they found a cheaper way to do it. Is often the case. But I would hate to see that. I would hate for over the course of a project, over the lifespan of the design of the project, to turn over your design documents and have them not actually reflect the construction documents. Question? Yes.
You keep mentioning turning over. Could you expand on what you mean in your world of turning over? Is it just here you go, here's my Revit model, or this Revit model is really valuable to my company, here's a Navisworks model with proprietary, and you can't touch it, that's it. What do you do?
So the question was, what are we really handing over? What is it? Is it a database, right? Is it a RVT file? Is it a DWF file? Ultimately, it's all of them, right? And to go back to the idea of, the contracts up front, all that stuff has to be covered up front in the contracts. And every client's going to want something different. There are clients that really don't. They just want the 3D coordination. They're not going to use any of the information. They may not even realize the value of it. And, that's unfortunate. But there are plenty of clients that we deal with now that are going to continue to reuse that information for the purposes of, as it goes through the contractors, for the purposes of facility management, to be able to understand where all the elements are in the building for maintenance purposes, for cataloging equipment, for cataloging spaces, and they wouldn't be able to do that and use that information if we weren't around to help push that and develop that. So I mean, there's no one answer. Every client's going to be different, but I think we all have to kind of strive towards that. That kind of ideal scenario where, where everything that you've done, like I said, gets carried through not only to construction but also on the facility side for maintenance and things like that. I think that's really important. And from a liability standpoint, I don't know. Maybe you don't want to turn over an RVT file. Maybe you turn over a Navisworks file. Maybe you turn over a DWF file with an associated database. Probably. I mean, ultimately, I think clients are going to reuse the database more than anything else, integrating into their own kind of facilities management system, right? So they're probably not going to be dealing directly with RVT files. They're just probably going to pull all that information in, and ultimately it'll still be linked. They'll still have some relationship, right, to some dashboard or what whatever the case may be. But I think it's the information, it's the database. I think turning that over is the most important thing. So content, I'm probably not going to talk too much about content now that I see this slide. There's a lot of debate kind of in the MEP companies whether to use manufacturer's content or whether to build your own content or whether to just kind of use generic content that came out of the box. Again, there's no right answer. The biggest point I want to make is that you follow some standard. So I'm going to talk in a little while about shared parameters, and I think shared parameters are really important for us MEP folks because, like I said, we're very data driven. In fact, if you look at the Autodesk kind of guidelines for shared parameters, I think like 90% of their shared parameters are kind of MEP parameters, not kind of general parameters or architectural parameters. And it wasn't really till the MEP folks started really getting into this stuff that shared parameters became such a huge issue in my day-to-day kind of activities. And I'll talk about kind of how I solved that problem. But the biggest thing I can say about using content is that make sure it integrates into your company standards. So make sure if you're going to bring in, I think that's like a train unit on the left, and on the right is something that came out from Autodesk. I mean, can you guys tell the difference? I mean, honestly, they're the same thing from a geometrical standpoint. The most important thing is the information that's inside of them, right? So things like airflow, horsepower, the electrical information, and making sure that information syncs up with your shared parameters and syncs up with your schedules so that your electrical engineers can take advantage of that. Now, that's the most important thing. I mean, who cares whether you downloaded that from a McQuay website or whether you had some intern, churn something out in the morning. I don't think, it doesn't matter, As long as it's accurate, it doesn't matter where it came from. But we definitely have a problem currently as far as standardizing shared parameters, standardizing things like subcategories for MEP families. There's no standard for that. I'd love to work with you guys to develop one, that we can all use. I'd love to work with Autodesk to develop one that we can all use. But we're just not there yet. So most importantly, you have to worry about yourself and your company and make sure that everything that you use adheres to your company's standards. So, I mean, unfortunately, there's that little ribbon at the top where you can import, content from Seek. And Seek is great. But unfortunately, the shared parameters kind of vetting and management of subcategories in Seek, it's not like religious. I mean, they accept stuff that doesn't conform to their style guides and things like that. So while it's great for grabbing stuff quickly, ultimately you're probably going to have to modify some of those things to work with your company's standards. You guys have any thoughts about content? Yeah. No, I can see a difference there. So one of the comments was, it should be linked to your LOD. Absolutely. I mean, I'm a big proponent of just putting out like solid masses for like, at a conceptual level. Because the great thing about Revit is, you can just highlight all your, assuming that you've sorted it either by type or by family. You just grab all of them and say, all right, I'm going to swap that out with something real. I'm going to swap that level 100 stuff out with level 200. You can do that with a click of a button. So I'm a proponent of that. If it's faster and you don't want to show too much level of details, you just want to show a box for SD, that's fine. Because you can always swap it out later. Some people don't. Some people will drop that in, and then what I would sometimes do is I'll drop in something real like that, maybe from a manufacturer's website. I'll just wipe out all the parameters, just clear them right out, so that there's no misunderstanding. So that when those drawings get printed, there's no misunderstanding that I may have specified something that I didn't need to. So you can do it both ways. But yeah, it's important. Like you have to adhere to those LODs. Whatever you agree to, don't show level 300 during SD. Just don't do it. So I agree with you. Yeah, definitely. Matt, you were going to say something?
No, I just agree. There's certain families you get from manufacturers that show every bolt around a flange.
Yeah.
While that may be great for the heat factor or for renderings, in reality, does it really matter from a contractor's perspective whether there's 8 bolts on a 300-pound flange or 6 on a 150-pound flange? It's just load for your model, and it's just extra detail. So I think manufacturers get a little bit overzealous sometimes in terms of what they're adding to these families. Yeah.
Yeah. I mean, and Matt's comment was that don't overdo it. And in fact, sometimes you may deal with manufacturers that overdid it. And I completely agree. And there are guidelines. Again, the Autodesk style guide is good because it'll give you kind of like like a range that your family sizes should be in. To kind of keep the model kind of up to speed. So yeah, I completely agree. There's no reason to model nuts and bolts and screws, and you don't need to model duct hangers and things like that. That's a good point. Yeah, in the back.
Agreeing with all of that, I would say that there's one component of the physical information that is important. That's the location of connectors.
Yeah.
So if I'm using a piece of generic content and my error takes on the wrong side of the unit, I can have ramifications. So I'm just interested in how you reconcile the generic content with, let's say, specific content in that book.
Yeah. So to kind of paraphrase the question is, how do you deal with specifically the question was location of connectors and possibly, what it makes me think of is the question, which is, now are we specifying specific manufacturers? Have we now gone away from being able to specify 10 manufacturers? Because now ultimately I've modeled a train unit. So does that mean that the building only works with a train unit? Does that mean that I've now pushed out all other manufacturers from being able to bid on the job because I modeled I downloaded a train unit? So I mean, it's a great point. What I've done in the past is you kind of have to go with you're right. I mean, you're not going to get connectors in the exact location on different manufacturers' equipment. I can't argue with that. But you're going to have to kind of work with content that covers like the majority of what's out there. And let's be honest, I mean, there isn't a huge difference. Like that train rooftop unit, McCoy makes an identical one, Aon makes an identical one. Yeah, the connectors are off by a couple inches, but in general, the side that you connect onto is this. They offer both, right? But again, it goes back to my point where if you specified a right side connection, that's in your schedule. So if you maintain that link, that's the most important thing because it's right there on the schedule, right side connection. And because it's linked, that model has a right side connection. So there isn't that kind of that disconnect anymore, right? So what you schedule is what you model. So if you wanted that right side, that's what you got, So it just goes back to that kind of guys, you got to use linked schedules. Still, I deal with companies that are using AutoCAD schedules. You got to get away from it. It's crazy. Can't say it enough. So I'm going to talk about shared parameters. So this is something that I worked with a coworker at Kling Stubbins. Phil Cunningham. He's out on the West Coast now with Hvac. He's a really smart guy. So he kind of got me into doing some like BV macros in Excel, which I had never done before. So he kind of started it, and then he eventually left the company, and then I kind of continued it on into something a little bit more kind of a little easier to use. So like I was saying, and this is actually this Excel spreadsheet is from the Autodesk style guide. So they give you a shared parameter list to work with. And everybody knows about shared parameters, right? I don't need to go into them. I mean, they're basically the link, the data link for your information. So if you want to have some type of identification of anything when it comes to an element, it needs to have a parameter. It doesn't have to be a shared parameter, but the benefit of the shared parameter is that you can pull that information from multiple places, outside databases, internal databases, schedules, things like that. So that's the importance of the shared parameter. So the thing about MEP, folks, is that almost every single parameter is scheduled, right? I mean, you see these Schiller schedules, and they like run off the sheet. We schedule absolutely everything. So it really didn't become an issue until, MEP folks really started using live schedules and using all this linked information. They're like, how can we manage all these shared parameters? So what we tried to do was, build a spreadsheet. Since it's a text file, it's tab. It's tab delimited, so it's all text. So we just pulled it into Excel, and we built some macros and some stuff just to help you kind of manage it. So you can import old shared parameter files that you may have worked on in another project. You can kind of filter out all the duplicates. You can create new ones. You don't have to create, for those of us in the past, before I used this, before there were binding tools, and on the bottom, I rebuilt some of the sample SDK stuff that Autodesk has to be able to bind these parameters. So these parameters live in this text file, right? And ultimately, every piece of content you have to bind them. It's like they call it binding. It's like a binding process where you literally take them and bind them to the piece of content. So the two biggest time-wasting moments in the office is having to deal with all these shared parameters and having to make sure that all your content use the exact same parameters, because that little unique identifier, that little alphanumeric GUID there, that's a fingerprint. So if you have a shared parameter called length, and it's got a different GUID than another shared parameter called length, guess what? It doesn't work. The program doesn't understand just because they're both named length that they have anything to do with each other. So yeah, so we built this spreadsheet, and oh, by the way, so the most important thing about this spreadsheet, this is free, right? So I built this with Phil and I continued to build it after I left Kling. And if you go to my website, openrevit.com, it's there. It's free. It's just an Excel macro. And so if you guys are struggling with shared parameters, download it. Just download it. Use it. Do you guys want to see this or not? Do you have any interest in seeing this? You want to see it? Yes.
I just got a question about, and it's a plumbing question, but Revit MEP. I'm an architect, and I tried to set up. I've been working pretty hard on the Revit MEP, and I tried to set up a plumbing fixture schedule.
Yep.
Where the piping sizes would appear in the schedule. I couldn't get it to work. I don't understand it because, the components show the piping sizes right there in the, in the information of the model of a plumbing of a water closet or a lavatory, but I wasn't able to, in any shape or form, bring the pipe sizes into the schedule. I don't know what I was doing wrong. I assume it was because I was kind of self-taught, but it was extremely frustrating because the information was there in the model, but I couldn't. You could go in manually and fill out and show the pipe sizes on the plans, but I couldn't get it into the schedule.
Yeah, I mean, so the question kind of was, one of the guys in the audience is having problems with pipe sizing and linking it up. It's there in the family. It's not there in the schedule. It leaves a blank. This is why shared parameters are so frustrating. I've been where you were, and there isn't always a good answer. So one important thing to understand is that there are certain system parameters, right, that are just hard-coded into components. And those are usually available across the board. You don't have to worry about them. So things like manufacturer, for example, is hard-coded into just every piece of content. You can't delete it, but the good thing is it's there. Everywhere you look, it's there. So size, I believe, is a system parameter. So pipe size is a system parameter. What I usually do is I will create, because when you're dealing with equipment, usually there's more than one. Usually there's more than one pipe connection. So you don't want just one parameter to represent pipe size. So usually I usually for the most part ignore the system parameters if I can, and I'll create my own. So maybe your best bet is create your own pipe size. Create your own pipe connection size parameter and link that up with the dimensions in your content. Because for example, an air handler might have might have 2 coils, that's 4 connections, plus drain connections, plus other connectors for ducts and electrical connections and things like that. So I mean, create a parameter for everything that you need to schedule.
So these are parameters that aren't in the default plumbing fixture schedule. How
right.
You go when you select the, when you build your schedules in Revit, you can select the generic type of schedule, but when it's not in the available field. So what you're saying is you have to make your own parameter.
Yeah, you have to make. You can't. You could never schedule what we schedule as MEP folks with the parameters that we're given to you out of the box. It's impossible, which is why you have to manage this, and you have to standardize it. So I'm probably running, I probably have a lot more to cover, so I'm not going to demo it, but the process basically is, this uses the Autodesk style guide. And the reason why I did that is so that there's just some standard that we can all measure against. So I use the Autodesk style guide. So you can import, assuming you use the style guide, you can import your parameters into here and it'll work. If you don't, you might have to mess with it a little bit, but the great thing is you can import shared parameters file. You can add new ones, through this, new parameter, that's it. You don't have to be in Revit. So what I was talking about, it's like you're clicking back and forth in that share parameter window, and then you're binding it to a schedule. It's the biggest pain. So you can do this all outside of Revit. You can create all your shared parameters outside of Revit. And then when you're all said and done, you can just check whichever ones you want. You can check them all, and just export it as a text file. What I've done in the companies I work for that works really well is what we'll do is we'll check off all the ones that will appear in a schedule. So for example, a fan schedule. We'll go and I'll check every single parameter that appears in a fan schedule, and I'll export that as a single file. And the reason I export that as a single file is because that tool down there on the right-hand side, and it's a plugin. I actually haven't released that yet, but now that I'm talking about it, I'll just throw it up on the website. It's not completely baked, but once you have that text file, you basically open up that fan, you click bind, it asks you where the text file is, you click the text file, you're done. All those parameters work. You load that into your project, it's all ready to be used in the schedule. So literally, over like 5-minute period, you can handle this. So what was taking an entire day, you can handle in like 5 minutes. So this is free. Check it out. I don't get paid for it. I have no ads on my site. I actually have a video here showing it. The video is up on the website. You can check it out. Walk you through how to use it. So one thing also I wanted to talk about was smart content. So, and only recently, so I don't know if you guys know Martin Schmidt. I don't know his exact role at Autodesk, but if you see anything, related to MEP, he writes a lot on the what's the blog he has? Inside the System, right? You guys know that one? It's an Autodesk blog. Most of the time, he's posting on there. And so he has some good stuff on there, and it's up on the wiki, the Revit wiki site, about using calculations inside your content. And so this got me thinking, because there's an API add-in that was freely available as part of the Autodesk Developer Network, and they kind of released these things. And what it does is I'm just kind of leading into what got me into how important this is and how you can use it. What it does is it takes, you run the load calculations inside of Revit, and I'll go into the load calculations in a bit. You run the load calculations inside of Revit, and it now embeds all that information inside the spaces. So what you can do is actually place air terminals. Depending on what you set as a delta T, it's going to calculate your airflow for the space. So what this tool does is it takes however many air terminals you have, or air outlets, I should say. So if you have 4 supply outlets, it takes the CFM required for that room and it divides it, in 4. And it'll update your air terminals automatically. And so that got me thinking, and I was like, well, since everything's interconnected, ultimately the terminal device sets, it's the circuit setter, right? In a system, the terminal device, the demand at the end of the system, that's what sets everything else in the system. So I was like, well, if you can automatically update that one piece, the most important component, pretty much, what about all the downstream equipment? Or I should say upstream. All the upstream equipment, right? The VAV box, all the VAV boxes connected to some floor air handler unit, whatever it is. What if you could run a load calculation, update all your airflow, and then have it automatically update things like the loads on coil loads on your schedules, flow through those coils, flow through all those terminal boxes. And remember, we're talking about schedules that are smart linked now. To be able to receive an updated architectural model, maybe they change the glass, you rerun the load calcs, cooling load maybe goes down, maybe goes up, hopefully it goes down. And with a click of a button, you could basically domino all your schedules in one click. So I was like, I put 2 and 2 together, and I realized, well, with this tool and the stuff that Martin was talking about, like, you can actually do this. So what I did was I loaded in that tool, and I started populating, rather than populating, and this is the example is a VAV terminal. Rather than populating this with information that you fill out, right? Because a lot of times you just fill out the schedule by hand, right? Rather than populating it with all information that's editable, I populated it with calculations, formulas. So you can use formulas in Revit. They're very difficult to use sometimes. Sometimes they're really straightforward. You can add two numbers together, right? But when you start dealing with if-then statements and greater than, less than, and you start dealing with multiple different types of units of measurement, that's the biggest problem. Start multiplying different units of measurement and canceling out units and things like that. If you don't do that properly, it doesn't work. So that's where Martin explained the whole thing, basically. And I realized that you could essentially do this. So, and I can demo this too if you guys want. But basically, you click, and I guess I can open it up in the background since it's actually pretty cool. I'll come back to it. But basically, what you do is, you rerun your load calculations. I know most of you are not doing load calculations inside of Revit. I'm going to talk about that. You're probably doing them in train trace. But again, there's ways to bring that info back in. We're talking about information here. There are links. There are database links, GBXML, file transfer formats. Whatever your load calcs are, wherever they came from, while it would be nice if you do it inside of Revit, right, that single source, just bring them in. Run this, updates everything. Is that good or is it bad? It might be a bad thing. Maybe that's too much for some people, right? One click and you walk away and you don't look at your schedule, right? So I mean, the point being, it's pretty cool, right? And it's doable. And I mean, that's really the holy grail, right? And you can actually do it. This works. You can do this right now today. And nobody's doing it. Most people are not doing it. The family file sizes? That's a great question. I'm not sure. I'm not sure. I know that I believe I've read that formulas can have an impact on file size. Yeah. So I don't know how much. Yeah, you can answer.
I've always found that the more that we're asking the database to update right away, the heavier the process is going to be. Like our ability to turn off the way that Revit structure analyzes. That's great. If we could do that to MEP, it would be very helpful. Like we can go into Revit structure and say, just stop analyzing until I ask you to analyze. Revit MEP, we can't do that, right? We can't say, stop checking, stop processing, stop.
Well, no. Well, you're partly right. Yes. I mean, there are calculations constantly going on inside of Revit, and you can't shut them all off. But they did. If you're not familiar with, in 2012, they did allow you to turn off calculations on a system per system basis. So if you don't want to calculate flow and you don't want to calculate pressure drop across a piping system or a duct system, you can turn it off. So that it's not every time you move something, it's not recalculating static pressure and things like that. You can turn them off temporarily, turn them back on when you're all done. You want to do your calcs. You turn them off completely. If you're not using static pressure calcs, turn them off. It's really only like a handful. For those of you that are not here, there's maybe like 5 MEP folks here. So a lot of what I'm saying, it's falling on deaf ears, but that's okay. It's okay. I wanted to show this.
Where's that located?
Oh, so there's the question was where can you find this stuff? So again, if you go to my blog, the search tool actually works pretty well on my site.
No, I think that's like disabling the system from being analyzed.
Oh, I'll show you that. I'm going to open this up. Yeah, I'm sorry, I got the wrong question. The question was, where is this toggle for turning things off? I'll show you that.
Alan, we're about 40 minutes into it, or 45 minutes.
So how much time do I have?
20 minutes more.
About 20 minutes? Okay. All right, so whatever. If I don't get to show you that, again, go to the site. I've got links to, and so I'll answer your question because I might not bring it up. But anyway, I've got links to all the articles so that on the Autodesk wiki. Like, I'm not taking credit for this at all. Like a lot of this information came from the wiki from Martin Schmidt, and that tool. I had to tweak it a little bit so that it works with my air terminals, right? Because you have to know what the parameter name is for airflow. But that was so simple. So you can do it yourself, trust me. Those two things, I didn't create those. I just put 2 and 2 together, and anyway, hopefully you guys look into this. Anyway, if you go to the site, you can check it out. But to answer your question, if you now there's a new category. I guess yeah, it's a new like family category in 2012.
Is it in 2012 only? Is that option in 2011?
It's new in 2012. So you don't care anymore. All right. Well, for everybody else, under piping systems, if you go into the type properties of the piping system itself, so let's say you have a chilled water supply system. You go to the type properties of that system, there's a calculations parameter, and on the pull down you get nothing, flow, or flow and static pressure. Flow and pressure drop, something like that. So I'm going to keep cruising, and I know I'm probably ignoring questions. Okay, good, no question. I think. Yes. So that's that video.
In your formula-based laying out the system, how successful have you been in that magical moment when you have to break a formula, like try it onto a big balloon and you can't fit an air handler because it's got a balloon in the way, you've got to break your perfect system?
Yeah. Don't break the system.
Okay.
So yeah, I mean the question was, what if you have to break the system up for what? Just for because of the visualizing.
Actions of, you can't fit the perfect system in a certain point because the structural re-engineered beam, or the compromises you make.
Well, I mean ultimately, if you model it and it doesn't fit, I mean you're going to have enough problems running into modeling something and it actually modeling it and it fits, and then they go to build it and maybe it doesn't fit. That's an issue in itself. If you're modeling something and it doesn't fit, someone tell somebody. Run clash detection, please. There's built-in clash detection, guys. You don't have to use Navisworks. If you please use Navisworks at the end of the week, at the end of the month, a couple of weeks before you have a deliverable. But on a day-to-day basis, you're working on a floor, you can highlight all this stuff and do a clash detection inside of Revit. You don't have to export it to Navisworks. Do that. I don't talk about clash detection today, though. So calculations, okay, so probably have like 15 minutes. So calculations and analysis. So the good thing is I probably already talked about this. So there are built-in heating and cooling load calculations. They conform to the ASHRAE, RTS method, I believe. I'd have to look that up again, but they do conform to the ASHRAE calculations. They're all based on creating these spaces, right? Volumetric spaces. So that's probably the biggest thing is, can you create, it doesn't always understand volume, the correct volumes, especially when you're dealing with very complex, architecture and kind of very, complex designs. But it does work. It might take a little finagling to get all the zones, spaces set up correctly. But basically, what you would do is you just place spaces everywhere there's a room. Place a space. It's going to try to basically go as far out as it can until it hits the boundaries of the room. That's your volumetric, your analytical space. Run your heating and cooling load calculations. If it bumps up against a window, it's going to know that there's a window there. You can set. It doesn't pull architectural performance information, right? It's based on GBXML, so there's a set. This is what people often don't understand, and I've heard both arguments. Why doesn't it just pull the R value of the architect's wall? First of all, I don't want to do that. I don't trust the R value that the architect has put in their wall, right? No offense. So I get to define it. So maybe I set it at the code minimum. Code minimum, this is the wall. So, or maybe you go beyond that. Maybe you're a little concerned that they're going to change the design or you don't trust their number. You can set that as an engineer. So you can set the performance values of the glass, the walls, all the boundary conditions.
When you do that, it's important to communicate those assumptions you built into the MEP model, right? What the architect might be doing is thinking one thing and setting the values one way. The engineer is now setting the values on their model another way, and they could be radically different.
Right.
Or one may exist, the other one may not.
Yeah, the question was, why is our equipment so oversized all the time? No, the real question was, there has to be transparency in those values. And if there's anything you take away from this, is that BIM hopefully really breaks down that wall that opaque wall and kind of builds that transparency between the design teams. So yes, you should be completely upfront if you don't trust the numbers, if you're going to be doing load calcs that are different than maybe what you've been told are performance values. But the point being is that you're able to adjust these, so you're able to tell what spaces are what. That's an office. That's a classroom, whatever. It pulls in kind of ASHRAE templates for things like internal loads, just like any other load. It's basically like any other load software, so it's going to pull in template information. Yes.
Is it connected to the room spaces that architect puts in the architecture room?
Yes. Well.
So you take it from there, like a
Yeah, the question was, is there a relationship between the architectural rooms and the HVAC spaces? They are two completely separate elements, but you can pull information like, room names and stuff like that. The volumetric kind of, the building of that analytical volume uses basically the same kind of way the room volumes are calculated. So they are very similar to each other, but they are two completely separate elements, rooms and spaces.
The spaces, they're needed because there are things that are in the MEP model that architects aren't paying attention to, like the space above the ceiling, below the slab. They have to know that volume and so forth. So they are essentially rooms with an additional behavior, but you can make them not monitor the data.
Yeah, they have way more information, the spaces. Information that's required to do these calcs.
Yeah, because also the model you may end up getting two room spaces that are used for the collaboration purposes.
Well, the good thing about spaces, also is that you can split one room into two spaces, right? Because maybe you have two independent fan coils, one serving a very load-driven side of the room and the other serving a not so load-driven side of the room. And you want to know how to, you can put a space separation in there just like you can do a room separation. Calculate both. These are techniques that everybody knows, at least engineers we know about, we do it, and you can do those same techniques in here. And you can adjust every single value in here. So while it pulls templates, you can go dig down into a space and say, just like any other loads calc, and say, don't pull from the template. I want to specifically say that this room has a very high occupancy density. You can adjust all those values. So whether or not you use this, at least start using it, start testing it, comparing it against the other tools that you use, because what a great set of information to work off of as designers and engineers, to be able to pull in one of the most critical portions, one of the most critical calculations of our buildings, which is the heating and cooling loads. So leading from load calcs, I'm gonna go into, and I think I'm at the tail end here. So if you're thinking about leaving, stick around for the last 10 minutes. So one thing I want to talk about is how you can now not only do load calculations, but you can also, you can carry that model on through for your whole building analysis, right? So we're in a time now where almost every building usually uses the building performance, method. You need to do a whole building analysis in order to meet code, to meet LEED, to get tax incentives. Almost every building has an energy model now. And one of the worst parts about energy models, again, is having to recreate all that information and all that data that's lost along the way. Building geometry, performance values, all the things we talked about, what type of spaces they are, what type of HVAC systems you use. All that information in the old way of doing things is you go into eQuest, you go into train trace maybe, and you're going to rebuild all that from scratch. And then it changes, and then you got to find out what changed, and then change. You got two completely parallel things going on at the same time. So while this isn't perfect, this kind of translation into a whole building analysis, it does work. Like I've done it. It does work. It's all dependent on how well you can create kind of a tight building, tight spaces, get surfaces to match up correctly, get correct volumes. Assuming you get all that ironed out, it does work. So there's a couple workflows we've been dealing with as of late at Case for doing whole building analysis, and one of them is using Vasari. So I know that a couple weeks ago, I guess Matt and who talked to Zach Cron talked about using Vasari for performance analysis or just analysis in general. So one of the workflows is, if you guys haven't used Vasari, it's kind of like a standalone kind of simplified version of Revit, basically for doing conceptual massing and conceptual analysis and things like that. It's pretty flexible. It's pretty cool. You should check it out. But so one of the things that we've been dealing with is building kind of conceptual masses in there, bringing them into Green Building Studio. This is a direct link there. Bringing them into Green Building Studio, doing some sensitivity analysis, and actually taking those buildings, and there's actually a direct, if you guys haven't used Green Building Studio, it's pretty cool. And one of my favorite features is that you can take a building, you can take it from Vasari, you can take it from Revit, you can take that GBXML file, you can upload it to Green Building Studio. You can't do whole building analysis inside of Green Building Studio, but the great thing about Green Building Studio is that you can export the two or three, we export three things. You can re-export the GBXML, bring that into a compatible platform like Hvac, Traintrace, something like that. Or you can export to two of the most widely used engines, Do2 and Energy Plus. So you can take your Vasari model, you take your Revit GBXML model, bring it into Green Building Studio, do some analysis. Maybe you don't do any analysis. But then you can dump that file into eQuest, and you can dump that file into Energy Plus. And it does work. So I know this is a simplified building, so you guys are looking at it and you're like, oh yeah, of course it works with that building. But I have to at least prove the point that it does work. So that top, do I do this in the right order? So the top one is a Vasari model. The one in the middle is the eQuest model, and the one on the bottom is an Energy Plus model in OpenStudio in SketchUp. And I didn't do anything. I didn't touch a thing. I just went from one to the other to the other. And it pulls in those performance values. Sometimes it pulls in the HVAC systems. I found sometimes it doesn't. But in this case, it pulled in the HVAC systems. Those HVAC systems are built out in eQuest. Those HVAC systems are built out as HVAC templates inside of Energy Plus. And those two, along with the GBXML, you could use another tool. Those two platforms are compliant for Appendix G modeling and tax rebates, tax incentives. Those are compliant. Green Building Studio isn't. So you're going to end up ultimately using one of those compliant tools. And the great thing is that there is a workflow to go from the architect to your loads model to a whole building analysis. It's not perfect, but believe me, it does work. It does work. It's possible. So I think that's probably pretty good on time. I think that was.
Other questions online? You want to check that?
Yeah, hopefully I'm checking these questions properly because it seems like it's the same question. Oh, thank you. So this is how you do it. I'm interested in hearing more about the shared parameter sheet. Okay. Well, I think I ran out of time, but there's a settle down in front. I think I ran out of time, honestly. But again, if you go on my site, I have a video explaining it, and all the files you need are right there, free. Yes.
I do have one question. Over the last decade or so, Revit became one of the mainstream BIM tools, and also ArchiCAD and vendor architecture. As architects adopted the BIM process, no matter what the tool is, years, 5 years, and Revit MEP come on board, and we're asking engineers to also participate and generate models. I'm seeing some of the same acceptance curve that I saw with the architects, where we're early in the schematic phase of the project. Engineers will want to produce 2D line drawing type documents, even in the model. They'll still want to draft it. And over the years, I've gone through trying to get people to say, yeah, let's model the stuff earlier and not do 2D stuff at all, or maybe just for the very beginning part of schematic. From your opinion or your observations and other engineer observations, how does that sound? Is that completely out of line in terms of the process of design? If architects dealt with it, but engineers seem to be in a different spot. What is your perspective?
Well, as far as modeling early on, I don't feel that modeling early on as MEP engineers is a good thing. I do believe that early analysis is a good thing. I believe that early equipment sizing is a good thing. Placement of that equipment is a great thing. Modeling out systems and routing and things like that early on, that's tough.
You still advocating doing the 2D system?
Well, no. Okay, so I just want to make something clear about 2D systems. Like, one of the great things working at Kling, and one of the reasons why I learned so much there, we threw away CAD. One of the best things you can do is throw away CAD. That's a personal opinion. Okay? Because it's a crutch. And I don't think, if you're going to go and sketch something out in CAD, well, in that case, if you're going to go to the effort of doing it, do it inside of your BIM platform. Do it inside of your model. And with 2012 now, they heard us, or they heard some of us, and they have now the why am I going to forget this now? The what's it called? Yeah, it's like placeholder. Thank you, Matt. They have placeholder systems, which is basically single-line systems. Except, what's the great thing about them? They have embedded information. So even though it's a single line, and it's how you would typically draw, maybe like an SC level kind of routing layout. It has a duct size. It has flow to it. It's a connected system, right? So if you do these loads and you put in air terminals, there's airflow through there, even though it's a single line. And but it's able to, you work much quicker, right? You can move things around much quicker. You can lay things out much quicker. But hold on one sec. The best part is you can expand those. So you can highlight that whole system, say we're good to go, expand it, boom, you now have your 3D. You start doing physical coordination, spatial coordination, I should say. So with that, I think you'll see more and more schematic layouts early on in design, more companies wanting to do early modeling, but utilizing those schematic tools, not utilizing full-blown tools. I think it's a lot to do up front, I think. Again, that's my personal opinion. If you're able to do it at your company and still be profitable at the end of the project, congratulations. You're doing really well then.
Yeah, I mean, as an architect, I'm interested in sort of like order of magnitude, where the big duct is going to go, where the wire case is going to go, just a general layout that does start informing the architecture as well. And you kind of want to know that earlier than later.
Yeah.
Obviously, you can't necessarily hold all the designers, engineers, and the architects to the schematics that you're trying to figure it out. So it's definitely a chicken or the egg kind of thing.
Yeah. Don't get me wrong. Still, you still have to do the old style of sitting down and doing a ceiling sandwich. You still have to do it, right? Don't waste 3 weeks modeling stuff and then go back to the architect and say, we don't have enough room in the ceiling. Just sit down with them. Don't open up Revit. Don't open up anything. break out your pen and paper. Let's draw up this ceiling sandwich. Let's get all the trades in there. Let's sort it out. You solve it in an hour. All right? There's still, believe me, I'm not completely throwing away hundreds and hundreds of years of architects and engineers working together. There's a lot of stuff that still remains the same. Do it. I know Don had a question online on whether working at Case is awesome, and it is. You guys, if you haven't checked out Case's website, if you don't know, I don't know at this point how you don't know who Case is, but check out what we do. Send us emails. Go to Design Reform. It's like an e-learning center. There's a lot of videos. I'm going to hopefully be putting a lot more videos up on Design Reform. It's designreform.net, not .com. We post, e-learning stuff, again, free. Check it out. Send us an email. Write us on Twitter. Tell us what you're doing. Just reach out to us. We do some really, really amazing stuff. I'm really honored to be working with these guys. So, the answer to that is yes. Are there any questions, other questions in the audience? I know I went over like 100 things. Is there anything in here you guys maybe want me to come back and talk about specifically? I know I'm talking to like 2 engineers at this point. Do you 2 guys maybe want me to come back here and do anything? Yeah.
I can see, you develop a little bit more discussion about how architects and engineers build a better building.
Yeah.
Because I find so many issues where they don't realize what you guys are looking for. They move things all over the place in the model. They're not really caring about what they're giving you. So maybe a little discussion about best practice of working together.
Yeah, I think kind of team best practices is something we should all sit down and take more than an hour to talk about. So yeah, I agree. I would definitely love to come back and talk about kind of the team atmosphere and collaboration. Sorry. Oh, content? Yeah. Yeah, I could come. We could talk. I could talk about content for weeks.
Okay, why don't we wrap it up there? So, thank you to Alan.
Thanks, guys.
Also, thank you to Microsoft for supplying all the food and great stuff. Great, and also my beer.
I spelled something wrong?